pleasant day, STEM learners. This is Sir Peter, your pre-calculus teacher. This is now the second part of our week number 7. This time, we will talk about the summation notation. So at this end of this video lesson, you should be able to illustrate a series as a summation notation and vice versa. So suppose you are asked to write the sum of all even numbers between 1 to 100. Is it difficult to write? Yes, it's difficult. How can we illustrate a series into a simpler notation? So mathematicians use the sigma notation to denote a sum. So we will be using this Greek letter sigma. So it is the uppercase Greek letter and is used to indicate the sum of numbers. So if the given series is consisting of several components or parts, then let that function be an expression involving an integer I. So usually we represent I as our integer. So the sigma notation is represented by this symbol. We have the summation of f of I from I is equal to m to n. Notice that there is a number on top of the sigma symbol. This is what we call the upper limit or the upper boundary. We have the m. This is the lower bound or a lower boundary or the lower limit. So the lower limit will be the first value of I, while the upper limit will be the last value of I. And I is the index. Sometimes, aside from letter I, we can also use X, N, J, or K as representations for the index. The given function is located after the sigma notation. And that every term in the sequence are called the summand of the summation. Let us take this one as an example. Expand the given summation and simplify if possible. The first given is we have the summation of the quantity 2i plus 3 from I is equal to 2 to 4. I will repeat how to read the given notation. We have the summation of the quantity 2i plus 3 from I is equal to 2 to 4. To answer that, let us expand now. So we put an equal sign. Then we continuously substitute the value from the function 2i plus 3. So we will start with the lower boundary. So we start with 2 times 2 plus 3. Plus, the next number will be 2 times 3 plus 3. And the last term will be 2 times 4, which is the upper boundary, plus 3. Simplifying the operations inside the brackets, so we have 7 plus 9 plus 11. And the final answer will now be 27. This 27 is now the value of our series. Let's now have the next example. So first, let us read the summation notation. So we have the summation of 2 raised to I from I is equal to 0 to 10, to 5, I mean. I repeat, the summation of 2 raised to I from I is equal to 0 to 5. To expand the given summation, we continuously substitute 2 raised to I, starting from 0. So we have 2 raised to 0 plus 2 raised to 1 plus 2 squared plus 2 cubed plus 2 to the 4th plus 2 to the 5th, which is the last term of the series. We evaluate now the exponential expressions. So we have 2 raised to 0 is 1, 2 raised to 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, and 2 raised to 5 is 32. Adding all the terms in the given series, we have 63. So therefore, the summation of 2 raised to I from I is equal to 0 to 5 is 63. I hope you understand. So when you do your modified assessment, even if it's multiple choice, you still have to submit your scratch papers showing the solution following this format. I hope that is clear. Next, we write the given series into a sigma notation. So it's the reverse. So we are not expanding, but we are writing this expression or series into its summation notation or sigma notation. So notice that we could use I as a representation. First is to determine how many terms will this series have. Obviously, if it starts from 1 going to the denominator 100, so meaning there are 100 terms in this given series. So you can conclude that the upper boundary might be 100. So we write first the sigma symbol, and then we put 100 on top, which represents the upper bound or upper limit. And then we write I as a representation for the index. And of course, it will start with 1. And then we represent it as 1 divided by I. So this is now the summation notation representing our given series. Let's have another example. What if we have -1 plus 2 plus -3 plus 4 plus -5 plus 6 plus -7 plus 8 and so on up to -25? Notice that there are alternating signs in here. So how do we deal with alternating signs? So first is we have to determine how many terms do we have in this given series. Obviously, from -1 to -25, we will have an upper bound, which is 25. So we can write it as the summation, and the upper bound is 25. And of course, our index I starts with the lower boundary 1. But the problem is the formula. So again, the formula has I, but the problem is how are we going to write the alternating signs? So the alternating signs are represented by -1 raised to I. So this is the correct answer. Notice that if the value of I is odd, then -1 becomes negative. So we have -1, -3, -5, -7, up to -25. Well, all the even numbers, 2, 4, 6, 8, and so on, up to 24, will have positive value because A negative 1 raised to an even number will be a positive integer. So therefore, the answer is the summation of I times negative 1 raised to I from I is equal to 1 to 25. Next, we have a sub 2 plus a sub 4 plus a sub 6 plus a sub 10 plus and so on a sub 20. Some students might think that there is 20 terms in this given sequence, but actually there are no 20 terms in there. Instead, there are only 10 terms from a sub 2 going to a sub 20. So be careful about that pattern. Okay? Even if you see 20 there, it doesn't mean that your upper boundary will be automatically 20. So instead, we write 10 as our upper boundary. Then we use again the letter I to denote our index. And of course, it starts with 1 as a value. And then notice that A is constant. So therefore, A is included in the formula. And then how do we represent the even subscripts? To represent that, we could have 2 sub 2i. So therefore, the correct sigma notation for this given series is the summation of A sub 2i from I is equal to 1 to 10. Any question? Let's have the last example. We have 1, 1/2, 1/4 plus 1 over 8 plus 1 over 16 plus and so on up to 1 over 128. Notice that every value in the numerator are 1. So in the formula, we will have 1 over something. And of course, we write the summation. Now, when we list all the terms based from the pattern, we'll have 1 over 32, 1 over 64, and then 1 over 28. So how many terms do we have? Exactly, we have 8 terms in total. So if we start with I is equal to 1, then the upper boundary will be 8. But how do we represent the formula? Notice that 1 could be 1 over 1, but every term in the denominator has a common base, which is 2 raised to I. And then we have to subtract it by 1. So the correct answer is the summation of 1 over 2 raised to I minus 1 from I is equal to 1 to 8. Checking if the first, we are referring to the first term, we have 1 minus 1 is 0. So that's 1 over 2 raised to 0, that is 1. Then we have 1/2 for the second term. So we have 1 over 2 raised to 2 minus 1. So that will be 1/2, and so on. But there is another way to write the given summation notation. So what if we start from I is equal to 0? So notice that the lower boundary is now 0. So is it possible that we could have an upper boundary which is 7? So we can also write this one as 1 over 2 raised to I. So this is a simpler formula. Okay? If I am going to be asked which is more simpler, that is the second one. But this is also a possible answer. So both are correct, but this simplifies everything because this is applicable also to this given series. So in a given series, there is also a possibility that will be 2 or more possible answers for as long as you will still get all the terms in the given series. So here, are the references used in this presentation. Congratulations to everyone, because we are now done with quarter one. See you again on our second quarter of pre-calculus subject. Again, this is Sir Peter, your pre-calculus teacher.